Hello, my advanced algebra students. I'm super excited for this example because even though it might be even harder than what you see on the GED math test, it involves a review of so many different GED math skills. So anything that hits on a bunch of skills is good for me. So directions say, find the simplified area of each shape. Let's take a look at our rectangle first. Now, you might be panicking because it does not look the way you would expect it to look when you see measurements on a rectangle. Generally, we see things like 7 inches or 12 centimeters, but instead, we see a measurement of 3x plus 5 for our length and x minus 2 for our width. So don't panic. What we're going to do is I realize that we don't have the information about what x is. However, we're going to do as much as we can without figuring that out. So let's start the way we always do, which is if we're looking for the area of a particular shape like a rectangle, we can hit up the GED formula sheet. Very first section is the area section, and it will tell you that the area of a rectangle is equal to its length times its width. And you might say, well, Kate, I don't know the length. I know this weird random expression that's representing the length, and I don't know the width. Same thing. That's okay. Just plug in what you know. So the area is going to be equal to, what do we know about the length? We know it's 3x plus 5. But be careful, that entire length needs to multiply with the width. So you need to put the entire length in parentheses. And then same thing with the entire width. We have this x minus 2. This expression with two terms, and so we need both of those in parentheses to say we're going to multiply that whole thing by the other whole thing. And now we can use our lovely foiling technique. I can't believe I said foiling. You guys caught me. We can multiply here with, I never like to call it foiling. I have a whole reason why, but I won't get into it. But we can multiply here by passing out each term in the first parentheses to each term in the second parentheses. So let's start by passing out 3x. 3x times x is 3x squared. 3x times negative 2 is negative 6x. And now we're done passing out 3x, but it's time to pass out positive 5. Positive 5 times x is positive 5x. And positive 5 times negative 2 is negative 10. And now I did that multiplying. We do want to continue simplifying, though, until there's nothing more I can do here. There's not a whole lot I can do, but I do see that I have some like terms. Negative 6x, that's an x term. Plus 5x, that's also an x term. And so we can go ahead and combine those. Negative 6x plus 5x is negative 1x, but of course I'm a mathematician, so I just am lazy, and I write negative x. And then I'll drop my negative 10. I'll drop my 3x squared. So what is the simplified area of the shape? Well, our equation here says that area is equal to all that jazz. So there it is, all that jazz is the simplified area of that rectangle. And yeah, that's as simple as we're going to get it if nobody tells us what x is. All right, let's look at the square now. Again, we're finding the simplified area of each shape. And if you were to hit up the square formula, which you are totally welcome to do, you would get this. A is equal to s squared. That is specifically the area of a square formula. But be careful when you're plugging into this. So we do know our side length of our square is this algebraic expression 2a minus 7. But don't just plug in 2a minus 7 and then pop a square on there. You want to take this whole thing and square it. So make sure you use parentheses. Now, another really common error that students make is they assume that just like when you're multiplying by a single number, you can pass it out. They assume you can also pass out an exponent, which is not true. That is wrong. So what you should always do here when you see that square is expand it. Remember what it means. To square something means to multiply it by itself. So the quantity of 2a minus 7 squared is the same as taking all of 2a minus 7 and multiplying it with itself. Now this is interesting because another way to think of this is a square is a kind of rectangle. I mean, it's a special rectangle where the two sides are the same, but it's a rectangle where the width and the length are the same measurement. And so you could have gone straight from the rectangle formula, a equals length times width, to there. But either way, you'll get to the same place. And now let's multiply it out. So 2a times 2a is 4a squared. 2a times negative 7 is negative 14a. Done passing that out. Time to pass out the second term. Remember to take the negative with it. Negative 7 times 2a is negative 14a. And negative 7 times negative 7 is positive 49. And once again, there is a little bit of simplification I can see right there. 2a terms, a negative 14a and another negative 14a. I need some space. Oh, I'll just write up at the top here. So let's see, my a is equal to, sorry, user error. A is equal to, there's no other a squared term, so 4a squared. But I can combine that negative 14a and negative 14a. Now careful, don't zero it out. Do it in your calculator if you need to. But if you're already at negative 14 and then you subtract another 14, you're going to be at negative 28. And then there's no other constant term, so it'll be just plus 49. So what's the simplified area? 4a squared minus 28a plus 49. All right, and both of these, they're measured in square units, but that's not really the point, not that big of a deal. The main thing here is that you can get these simplified expressions. All right, strong work, super proud of you. Happy learning.